Good afternoon. I'm Kedar, and this is my colleague Anthony. We work at the personalization infrastructure team at Netflix. Our team works with multiple algorithmic engineering teams, and our role is really to provide them any infrastructural components that they require. One such component that we built was a workflow orchestration system that worked across heterogeneous environments. Today's talk will focus on that, and specifically we'll dive into some of the challenges we face with respect to Spark. Netflix has one primary goal. We want to delight every single member every single time you interact with Netflix. And the delight really means that we want to be able to help you find content that you will love and enjoy every time you interact with the service. Happy customers will play more, will watch more, and will retain more. The driving force behind our efforts is really the recommendations or the machine learning pipelines that drive the recommendations. So really for every one of our 80 million plus members, every time you are presented with a screen, whether on any particular device, it is something that has been personalized by you. And those recommendations, like I said, are driven by the machine learning pipelines. So when you look at the screen, all the images, we call them box shots. Every single image out there, the positioning is a recommendation, really. So from top to bottom, whether you take all the rows, whether the algorithm thinks you like science fiction, whether you like action, you like comedy, or maybe you like like visually striking documentaries that feature serial killers. Whatever it is, it's being recommended for you. Again, across every row, again, each movie or TV show is ranked for you. So in a left to right country, the thing to the leftmost is the one that we think you'll enjoy the most. People change, tastes change, people grow up, you discover newer content, or you have to search for something that you're looking for. And so what this means is we are continually trying to improve our algorithms. And the algorithmic teams do that via machine learning pipelines. So what is it at a very high level, like a 50,000 foot level out here? We take a set of users, right? We take a set of users and we say, hey, okay, let's do some feature training on them. So we'll take features like, what movies have you played? What movies have you rated? How much weightage do you give to movies you watched a year ago versus now? Multiple features, maybe hundreds of features. You take them, you give them some weights. You do model training, right? In these, you could use algorithms like logistic regression or matrix factorization, gradient boosted trees, whatever you want. You do the model training out here. Finally, you have multiple models, the model training and the validation. Really, the validation step is really finding the best model. Once we have the best model, we'll A/B test that model by publishing it to our online systems. Summarily, what we're doing is, if we found that, hey, you needed to scroll left or right, or you had to search for something, we're trying to see how can we improve it ourselves next time so that your experience is much better. This is a squint if you can image. It's just exploring this, the top diagram. What's happening here is we're getting a set of users. That's a Hive query. After that, we are doing some kind of massaging of the data, which happens to be a Python script in this place. We're trying to get rid of any biases maybe in the data that might have crept in. We went global. We are in about 190 countries right now. So there's one model the algorithmic team felt would serve well globally. Maybe action movies and martial art movies carry well globally, and maybe this model specializes in that. So this is a Spark. This is trained by Spark. However, there's some content probably that's region specific. Some content carries well in certain regions. So for each of our regions out here, we do a for, and we say, hey, for each of these regions, let's train those models. And this one happens to be trained in R. Finally, for the actual model validation, we have a Scala step that does the scrubbing. And once we have decided we found the best model, we actually publish it using Docker to our Java microservices that run in the cloud. So as we heard these requirements from the teams, one thing was very clear to us, that the algorithmic engineering teams needed heterogeneous environment. to support innovation, they like to stay with technologies of their choice and incoming or newer technologies. So whatever we built that would orchestrate these pipelines needed to work across a heterogeneous set of environments. So if it is R or R2D2 in the future, we needed to support that. Spark happens to be something that's used pretty heavily. So they said, hey, we also want native Spark support. What is native Spark support? It means like, hey, you need to be able to treat a Spark step or a Spark submit job as a first-class citizen of whatever you come up with. We also want to be able to have a single place where we want to go look at the logs. We also want you to understand what executors are and executive memory and CPUs are. And we also want to be able to retry when something fails. And not only that, if newer versions of Spark come, we want to be able to play around with the version of Spark that we like. In the previous picture, what we saw, the expanded picture with all the steps, if you think of it, it's an expression of intent. So that's the intent being expressed by the algorithmic engineer saying, hey, this is what I want to do, a logical sequence of steps. So we needed to build something that would orchestrate those steps, like, hey, manage, hey, you've expressed your intent, I'm going to make sure I orchestrate this across heterogeneous steps, across heterogeneous environments. But we also needed something that would separate out the orchestration from the actual execution. Mesos actually, when we started, Mesos has achieves that. It has also Spark support. So we separated out these two concerns. There's not just one team that does machine learning or algorithm engineering in Netflix, so we had to be multi-tenant. And multi-tenancy itself brings challenges. Spark on being multi-tenant has its set of challenges. And other than that, if you didn't know, my job is more important than your job in a multi-tenant environment is always true. So we have those challenges going on. Some interesting constructs came up, like a parameter sweep. I think many of you out in this room probably understand what a parameter sweep is. So they came up to us and said, hey, we want to spin up 30,000 Dockers in parallel. That is challenging in different ways. One is just like, hey, how are you going to download all the bits from the Docker registry? You're going to have to pull, how do you not saturate the network, right? These are all the infrastructural concerns. The orchestration engine, how do you make sure that you're actually able to scale across such large concurrent requests? And the user really doesn't care about how we do all this at the back end. From their perspective, they want to say, hey, how can I have a single place where I can go and say, across all the 30,000 requests that are going on, I want to see how many have started, how many have not started, how many are in, how many have failed, and not only that, find a needle in a haystack by saying, hey, out of those 5 that failed, can you show me which those were? And by the way, get those logs for me in a single place, and also show me the parameters that were passed to those particular instances. So a bunch of challenges came up. What we built is something called Meson, that ends with an N, not a S, which is a general purpose workflow orchestration and scheduling framework. We delegate the runtime execution to Mesos. It's optimized for machine learning pipelines and has some visualization components built into it. We blogged about it just a week ago, so if you wanted to read a little more about Meson from what it is as a workflow orchestration system, you could go read about it there. There are plans to open source it. So let's take a really high-level view of what Meson is. As I mentioned, we use Mesos underneath. So Meson registers itself as a Mesos framework. Sorry, that's the wrong. I clicked. Okay. So Meson registers itself as a Mesos framework. A lot of these components within Meson are all pluggable. So for the expression of the intent, we have a UI. We also have an API if someone wanted to do it programmatically. And we also have a DSL. So if someone wants to express how the orchestration should happen, we have multiple ways of doing that. We have the notion of steps, or those individual boxes, that those are pluggable too. So we do have the Spark step as an out-of-the-box step with core Meson. But if you wanted to write a custom step, if your company had something or a technology that we didn't have, you could write a custom step. So for example, in Netflix, we have our own custom steps that use Genie to go and get Hive data. Event manager. So if you wanted to actually make sure that your workflows are triggered from different sourcing systems, be it Kafka or some messaging system, the event manager is again pluggable. It is a Mesos-based scheduler, so we have all the reliability built in. We do make sure that Mesos stuff such as doing reconciliation, having standby masters in both the framework as well as the having standby masters from Mesos is all present. Finally, from a persistence, that is also pluggable. We use Cassandra within Netflix. You see out there that there's something called custom executors. Though Mesos provides us with the standard out-of-the-box executors, Meson has its own custom executors. I bring that up because in the next phase of the talk, as Anthony takes us through some of the details, he'll talk of Spark-specific stuff and get into the details of why, what are the benefits of such an executor.
Thank you, Kedar. So I'm going to quickly run through some Meson features, and then we'll do a deep dive into some of the Spark specific challenges and features we have. As Kedar mentioned, there are steps. There are standard steps that come out of the box. You see run Hive, Spark job, start a sub workflow, and things like that. And if that doesn't fit your needs, you could write your own. You write your own step and plug it into Meson, and it'll show up here. And you can see some Netflix-specific steps there as well. So what is a step, and how do we connect them? Going back to the example that Kedar was talking about, the very first step there was a get users. And it's a Hive step, and it has a Hive query is input, and it generates a data set. Data set is just an abstraction to like a location pointer in S3 or HDFS. So this Hive step can be connected to, say, a Wrangle data, which was the next step in that pipeline, which takes one input. And the way you connect them is just pass these parameters. So the output of the Hive step just goes into the data preparation step, which in fact generates two more data sets, and you keep connecting them like this. And the Spark jobs, our jobs, most of them always almost have like a list of parameters it needs to take, the input path or the hyperparameters and things like that. This is how you get those information down to each of those steps and connect them. How do we compose these steps? So here we just put them in a sequence. You could put them in a parallel fashion like this. Those three paths are going to execute in parallel. And then when they converge, the step F7 is going to run. Or you could have like conditional branching. Branching here based off of a condition, and you're guaranteed that only one of those three branches would execute. And this is a for each example, which Kedar talked about, launching 30,000 Dockers. You might launch 30,000 B6 followed by 30,000 C6 and D6. And each of those 30,000 parallel paths has their own context and own set of parameters, so you run in your own sandbox type environment in those paths. You also have loops and arbitrary cycles. If you notice something, these have like a structure. Like when you split the execution path, you join them together at some point later, and you use some constructs like and for each to join them. That helps us to do a lot of static validation and make sure we reduce workflow errors. So Kedar talked about the separation of intent and the execution. How do we specify the intent? I want to build a workflow. How do I specify the workflow? There are two ways to approach this problem. So you can go top down or bottom up. Top down, you start by saying, oh, these are the steps in my pipeline. You put those boxes together, and then you fill in the details. Oh, I want a Hive step here. I want a Spark step here. This step is complex. I will call a sub workflow and things like that. And the next level is you take it further down and then say, I'm going to pass these parameters around and save these data pointers, and that's the top-down approach. Another approach is go bottom-up. Provide the configuration, the workflow configuration in code directly. That's an example of the workflow DSL. It's a Scala DSL that generates exactly the same output that we see on the top. You see some example of how we construct the DSL and make expressing such complex workflows very simple. There are a couple of advantages of going from the bottom up. This is code. You could check it into your Git repo or whatnot and treat it like any other code. And especially if you're doing custom steps, you write your custom step and you want to compose them with your other standard steps. You put all of them together and then compose your workflow. So it's helpful in a couple of scenarios. Let's deep dive into some of these and see how Spark is integrated into Meson. One key difference between Meson and many other workflow systems out there is this two-way communication. Many workflow systems launch a process, monitor the process, wait for that process to exit, and react to that exit code. If zero, do something. If a non-zero exit code, do something else. We do that, and we want to do something more. The Spark jobs that we run are long-running, and we want to know exactly what's going on while it's running. Let's say it's run for many hours. We want to track what's happening inside those Spark jobs, or any other step for that matter. So we build this two-way communication between Meson and any of these steps that are executing. It's very interesting. Like Meson can now send like control signals to these steps, like a kill signal or like a drain your cluster signal and things like that. The other way communication is even more interesting, where the step can inform useful information which we display on the UI. The step can say a progress status, like a percentage complete type number back to Meson, or the milestones that the step has completed, log stream that Kedar mentioned. Or even the output, like rather than just an exit code, you could say, oh, I succeeded, here's my output. Oh, I failed, here's my error message. The communication, two-way communication is very useful. Let's drill down on this a bit with Spark step as an example. You might have a multi-stage Spark step, and you might want to say, I'm completed stage 1, I'm completed stage 2, and things like that. So this is like an example of a milestone, how it shows up on a UI. There's also an example down here. Let's say you have a counter, for example. You have an accumulator, or you're keeping track of how many records you process or whatnot. You can send them back to Meson as well, and we could see that on the UI. There's also like the final output of that step that shows up there. That's another example. These Spark step run for a while, and we all know here how important logs are in debugging Spark and fine-tuning Spark. We stream the driver logs as well back to Meson, and we can look at it while the steps are running. Another interesting use case we have is like Kedar talked about the feature generation step in that sample workflow. And we want to know the moment something goes wrong with that workflow. We put it in production and it's running for days or months, but we want to know when things go wrong. The feature generation step, for example, can output something called a feature importance every single day. And Meson can track these outputs as standard artifacts. These are like first-class citizens, which Meson tracks, and you can query them back. Here's an example where we query like last 7 days of feature importance and just draw a plot of it. So we know that certain features are, something is wrong with a particular day's run, alert on it or whatnot. These artifacts are also useful for an optimization technique called memoization. Say you have a long-running Spark job that generated some output, and the step decided to archive it as like an artifact. Now Meson keeps track of it, and for some reason, if you end up in a scenario to rerun that step with the same set of inputs, we could just use that output because it's rather than just going through that computation all over again. So this is just an optimization technique that this feature enables as well. Multi-tenancy, as Kedar mentioned, multi-tenancy is a very key requirement. Multiple teams are using this system. There are production jobs, there are A/B tests that are in live, A/B tests that are in development, and one-off ETL type jobs. So Mesos and Spark provides various levels of multi-tenancy. Like Mesos has resource attributes, Spark you can set your memory or cores or whatnot. What we build on Meson is higher level abstractions. What we actually need is job priorities, job queues, dedicated job lanes, preemption, that type of stuff. So we build those constructs on top of Meson based off of these lower level Mesos or Spark constructs. The multi-tenancy is like an ongoing work. There's a lot of use cases that we still like to cover, and also the support in Mesos and Spark are also like improving. So we are like using the latest features to support some of these multi-tenancy constructs. Another dimension to multi-tenancy is like cluster management itself. So this is an example of how a cluster looks. There are clusters for production jobs, a general population cluster. There are persistent clusters like HDFS cluster, and then instance type based clusters like high CPU, high memory, GPU instances and things like that. For example, we have a cluster where it's dedicated for we have like 64 gigs of memory, and it's dedicated for certain types of jobs. We want to make sure that like these smaller jobs don't go and end up there in that cluster and fragment that cluster, and it's reserved for like these dedicated jobs. So there's again resource attributes and roles is what we use to do that. It also allows us to do like software upgrades on these individual subclusters. Scale up, scale down of these clusters. Like a persistent cluster, we are careful scaling up and down. All the other clusters are we can freely scale up and scale down. Although, like when the Spark jobs are running, you really cannot just bring down the cluster. So what we do is like stand up like a parallel cluster and do like a red-black, let the cluster drain, and then send new jobs to this newer cluster. So that's how we do like red-black software updates and things like that. So where are we on a journey? So Meson has been in production for over a year now. Mesos and Spark has helped us a lot. Meson allows our algorithm engineers to use Spark along with other technologies that they have, like the way leveraging the existing investment that Netflix has. A lot of these pipelines are moving over to Spark or partially or completely. So you see some stats there. Spark and Dockers are like mostly used on this. We are running like hundreds of concurrent jobs. That's a graph of the jobs, not like resources, but jobs. So that's what you see there. It's been in production, and we are happy with this, and we'll hopefully open source this soon. If you have similar challenges, we would like to hear about them. I guess we have some time for questions, I believe. Yeah.
Great. Go and raise your hand. I'll bring them over. Let's give them a big hand before that.
Actually, I have a quick three-part question. One is, what do you use for the persistence of the execution flow, right? Because you didn't show any persistence mechanism there. What do you choose? And we need to have that for sure if you want to use Meson. Second question is, since you're AWS users, have you considered using simple workflow, which does similar things like this, including the signals back to the thing? So those are my two questions. And when are you going to open source it? Because we want to contribute to this. Looks interesting.
Sure.
Okay.
You want to take it?
Yeah. So I'll answer the parts that I remember the question. So for the persistence, it's pluggable. What we use is Cassandra, because Cassandra is used widely within Netflix, but that's what we use. I remember the last one, which was the open source one. Open source one, there is no official time frame. So I'll keep it as soon, because I don't know if I'm allowed to give a time frame at this point in time.
Yeah, the simple workflow. Sorry, this is the working?
Yeah.
So we looked at simple workflow services. Netflix has other workflow systems as well. We looked at other workflow systems in the open source thing as well. So there are some few key points that I highlighted which are different. So those are the reasons we went and built this.
And next question's from the left side of the room.
Okay. Oh, there you go.
So I had a quick question about what you meant by multi-tenancy. So it looked like on your slide you were talking about Mesos versus Spark. Do you mean Mesos plus Docker versus Spark on Mesos, or Spark on Yarn?
No, what we meant by multi-tenancy is just multiple teams running on the same cluster. So this cluster is actually a heterogeneous cluster. Behind the scenes, when we spin up this cluster actually has, it connects to Zookeeper, it has HDFS, it has some Zeppelin notebooks, it has Spark running on it, and as well as Mesos slaves, so to say, or agents as they're called right now. So that's the standard cluster that algorithmic engineering teams get. We kind of are responsible for the operations of that cluster, if you will. Like we are there to provide newer software and manage the operations piece of it. And when we said multi-tenant, is that if multiple teams get onto this cluster, each of them have their Spark jobs. They're all different shapes and sizes. So for example, some teams might have Spark jobs that require a minimum of 64 gigs. But that one way to slice it is like have the entire cluster of hundreds of nodes be 64 gigs, but that's not efficient from a cost perspective. So the other one is, again, like you said, the prioritizations and stuff. So when we said multi-tenancy, it's really multiple teams using Spark and other jobs on the same cluster.
So it's a single resource allocator.
Yes.
Yeah, that's correct.
Yeah.
Yeah.
Yes.
By the way, we are on Mesos, not on Yarn. So we just wanted to highlight the features we use in Mesos and Spark to achieve some of the multi-tenancy challenges we have. Sure.
So I had two questions about your memorization. I'm wondering if you have any statistics on how often you are able to skip one of your steps, and how you specify your steps in such a way that you know that they're not going to be repeated, because I assume that most of it is referencing other data that may have changed since it was first computed, and how you can tell that.
So there are a couple of scenarios there, but in general, a workflow, we didn't have a picture of a running workflow. If you look at the blog, you see a running workflow, and there's are like steps that are finished, and then the steps that are running. And if something fails at some point, you go and rerun that workflow. We know exactly what to track, and then we skip all the things that are run and only rerun the failed ones and things like that. So that's one part to it. The other part, that we could do automatically, because we know exactly what the inputs are, what the state of each step is. This one is like if user wants to specify, hey, if the input is this way and if I generate this output, I don't have to regenerate this computation, I can skip over this. So it's giving a little bit extra more control to the step developer to do things like that. That's what happens right now. Yeah. There's been requests to have an artifact from one workflow used in some other workflow. We don't have that yet. That's been a request that people have. Sure.
So this talk was all about Spark on Mesos and the system you built. An earlier talk from Netflix was about Spark on Yarn. So that's interesting that you guys are choosing both platforms. I was curious if you have any thoughts on why one is better for some use cases than another, if there are any particular pain points that you can contrast.
Yeah, let me see. It's just an artifact of when we started off, that time it was Spark on Mesos. Yarn support was not that much. I think we are two separate teams. We are focused more on the algorithmic engineering ones, and that's like the big data platform team, the talk that you had earlier. There's pros and cons to both. We chose Mesos as the resource scheduler since Spark began with Mesos at that point in time. So it's not like we haven't tried Yarn to say, hey, no, we didn't like this part of Yarn.
There's also another reason, which is Meson itself is a Mesos framework.
Yeah.
So this whole workflow system is on Mesos.
Awesome. Let's give him a big hand.
Thank you.